Hello, we're going to study fermentation today. Fermentation is a process in which sugar water is transformed into ethanol and carbon dioxide. People have known about this process for thousands of years, but they have known almost nothing about its nature until late 1800s. People were fascinated about fermentation and they wanted to learn more about it because they used it for bakery, for making wine, and we also use it for making biofuels today. Fermentation also makes a very good model to study the concepts of biochemistry. Today we are going to study the effect of temperature on the rate of fermentation. Many other manipulations are also possible when the protocol is modified accordingly. Stirring rod, magnetic stirrer, beaker, yeast suspension, 3%. 0.4 molar sucrose solution, carbon dioxide gas sensor, temperature probe, Gauling interface to connect your sensors into your computer, a plastic bottle as reaction chamber, a ring stand and 2 clamps to secure your sensors, a beaker to use as a water bath, ice to use in water bath, water at room temperature for water bath, hot water for water bath. Prepare your cold water bath, placing ice and some cold water in your beaker. From your yeast suspension that is stirring at a constant speed, transfer 1 milliliter of yeast into your reaction chamber and place it into your water bath so it regulates the temperature. Set up your clamp and ring stand. Connect your Gauling interface into the USB port of your computer. You will need 2 Gauling interface or a LabQuest Mini to connect your temperature sensor and carbon dioxide gas sensor into your computer. Connect your temperature probe into your Gauling interface. Connect your carbon dioxide gas sensor into your Gauling interface. Secure your carbon dioxide gas sensor. Secure your temperature probe. Add 1 milliliter of sucrose solution into your reaction chamber, which was placed in ice water. Swirl to ensure that they're mixed. And place it back into the water bath. Raise your clamps to insert the carbon dioxide sensor into the reaction chamber, and then secure your chamber in the water bath using your clamp. Also position your temperature sensor in the water bath. Now open your Logger Pro software, go to File tab and select Open. Go to Biology with Vernier folder and scroll down and select Yeast Respiration with Carbon Dioxide Sensor Setup. Click Open. It will show you the carbon dioxide measurement, but it won't show you temperature, so you must set it up from here. You click on this Gauling icon and find temperature probe here. That is stainless steel temperature sensor. And that shows you the temperature in your water bath. Now you can close it and start data collection. Data collection will stop after 4 minutes. Now data collection is complete, I will going to clean up my setup and proceed with the next part of the experiment. We're going to add 1 milliliter of yeast suspension into the reaction chamber and place it in the water bath. Wait for it to equilibrate. Add 1 milliliter of sucrose solution into your reaction chamber. Mix it thoroughly and place it back into your water bath. Insert your sensor into the reaction chamber and then lower it to your water bath. And then secure your temperature sensor inside the water bath too. Logger Pro is open, so start data collection for the second part of the experiment. It will ask you to if you want to store the latest one. Yes, you do. Now data collection is complete, I will going to clean up my setup and proceed with the third part of the experiment. Repeat the procedure for the third part of the experiment, which is hot water application. Wait it for equilibrating. Add 1 milliliter of sucrose solution. Mix it thoroughly and place back in the water bath. Place your carbon dioxide sensor into your reaction chamber and then lower it to your water bath. Secure your carbon dioxide sensor and your reaction chamber and then lower your temperature sensor inside the beaker of water. Now you're ready for data collection. Click collect button to start data collection. You want to store your latest run. Now data collection is complete. I'm going to plot data for rate of fermentation in a new page by creating a new page, clicking on this page button on the top of your screen, select add page and select new data set and graph and click OK. Now what are we going to plot here is temperature on the x-axis versus rate of fermentation. I'm going to obtain this information from the first page. I'm going to perform a best fit line by clicking on this linear fit button, and it will collect slope information from each of the runs. I will select all the applications here, all the manipulations, and it calculates some statistics along with slope and linear regression. This is for cold water, this is for room temperature, and this is for hot water. Slope, which is the rate of fermentation, is 4.23 parts per million per minute. And for warm temperature, room temperature water, it was 93.98 parts per million per minute. For hot water, it was 71.6 parts per million per minute. I'm going to enter this information in the second page on the Y column, which is rate of reaction. Oh, I select second page from here. 4.23 23, 93.98, and 71.6. 71.6. And temperature for cold, warm, and hot water, I will again obtain information from here. Latest run was hot water, and temperature for it is around 60 degrees Celsius. I'm going to select 59.1 since it fluctuated and it's the number in the middle. So I will select that number as the representative of the temperature. 59.1 for the hot water, 59.1. For room temperature, it was my second run. Temperature was 26.2. 26.2. And for the cold water, it has changed in decimal in the first place, so I will select 5.5 as the temperature. 5.5. And here it has plotted the data on the graph, but it doesn't look good, so I will just change the representation of this by double clicking on the data entry. I select options, select filled circle, and I will keep the color same. Now, as you can see, rate of fermentation has increased as we increase the temperature, and then it started to decline as we continue increasing the temperature, which means there is some optimum value for rate of fermentation in some warm temperature, and it gets the reaction rate gets slower as we increased or decreased the temperature of the environment. Now you can do further applications of this, changing the type of manipulation or doing more statistical analysis, but this is not the subject of this video, and that's pretty much it. We have measured the rate of fermentation in cold, warm, and hot water. We have observed that rate of fermentation has some optimum value at some warm temperature, and it declines as the environment gets cooler or hotter. Now it's your turn. Try formulating a research question regarding fermentation and test it, modifying the protocol just presented here.